Good morning. In this lesson, we are going to study about function. And the two main questions that we are going to answer in this lesson are, number one, what is a function and why do we need to study it? And number two, how do we identify a function? But before we go to the formal definition of function, let's do some intuition first of what is a function. And in order to do that, I'm going to use the website that is shared by my mentor, Gain Cruz Oloya from Naga City. And that website is the interactive simulation from the University of Colorado in Boulder named PHET. And we're going to use its function builder feature. So here's the function builder. Okay, in the function builder, let's start with a function that does not involve any number first. So what you can see here is you have this part as our input, and we call this as our domain. And in this part, you will see the output when we go through this function machine. We're going to put this as the input in the machine, and it will come out as our output here. And this group we will call as the range. So let's begin with this function. So let's put the input. We have this feed going through the function machine. And then it came out like this. Let's try this second image. And it came out like that. Let's try this butterfly. And now it's rotated 90 degrees to the right. Let's try this man. When it came out, and it's also rotated 90 degrees clockwise direction. So there is a rule that governs the pairing between the input and the output. And that rule is this function. And we call this as our function machine. The function is not the input. The function is not the output. The function is the law or the rule that govern the pairing of the input and the output. Let's try another example. So let's input again this feed. Let's go to the next one. Let's go to the next one. And let's go to the last one. What do we notice? All the inputs are black and white. And they are all rotated 90 degrees clockwise direction. And there is a mirror that gets the mirror image. That's why if you look at this one, if you rotate the man, it should be facing downwards. But because you are getting the mirror image, it's facing upward. So you can think of this as like a rice mill. You input the harvest, and then you go through the rice mill, and then it came out as white rice ready to be cooked. Or you can think of this as the hours of study. You spend, let's say, 5 hours, 10 hours, 12 hours studying mathematics, and you implemented your plan of study, and then it came out as your grades. Or you can think of this as something that governs how the hand sanitizer is distributed. You can think of this as your distance from that hand sanitizer machine. When you become closer, it squirts some amount of hand sanitizer, and the output is a hand with hand sanitizer. So a lot of processes, especially mechanical processes, can be thought of as a function machine like this. Now let's explore some functions that involve numbers. Okay, let's say this is our function. The number is to be added by 1 and then multiplied by 2. So let's input the 0. It came out as 2. Let's input the 1. It came out as 4. Let's input the 2. It came out as 6. And let's input the 3. It came out as 8. So what happened here? When 0 is placed here, 1 is added. So 1 plus 0 becomes 1. And then the result is multiplied by 2. So 1 times 2 is 2. When we input 3, 3 plus 1 becomes 4. 4 times 2 becomes 8. 2 plus 1 is 3 times 2 becomes 6. And 1 plus 1 is 2 times 2 is 4. So this machine controls how the input is paired with the output. Again, this set of inputs is our domain. This set of output is our range. This machine that acts as a rule is our function. And the rule says that you will get the output by adding 1 to the input, and then the result is multiplied by 2. And the result is this table of values. 1 is paired to 4, 2 is paired to 6, 3 is paired to 8, 0 is paired to 2. So that is what's going on when we talk about function. Now let's go to a more abstract way of looking at function. Now let's use an equation to represent a function. Multiply by -3, and let's say we are going to add 1. That 1 can be written as a function as y equals negative 3x plus 1, where x represents the element of this domain and y represents the element of this range. And the function is this linear function y equals negative 3x plus 1. What it means is when the input goes through the machine, it is multiplied by negative 3, so negative 3 times 0 is 0, and then added by 1, so 0 plus 1 is 1. When it came out the machine, it becomes 1. When 2 is passed through the machine, it will come out as negative 2, the same with 2, the same with 3. So let's analyze what happened to 3. 3, it is multiplied by negative 3 to get negative 9, and negative 9 plus positive 1 becomes negative 8. And you can select any input, let's say negative 4. It will come out as positive 13 because negative 4 times negative 3 is positive 12. Positive 12 plus positive 1 becomes positive 13. And the function also can be represented as a table and as a graph. So you have the equation negative 3x plus 1. And when the input x is substituted to this equation, the result is the y. So if negative 4 is the input, the output would be positive 13. If 0 is the input, the output is positive 1. So there is a pairing between the input and the output. And then this table can of course be expressed as a graph in the xy plane. So the x is plotted in the horizontal axis, the y is plotted in the vertical axis, and these points are now these points. And of course, we have this equation. So that is now our intuition about function. Function is simply the pairing of the input with the output, but what governs that pairing is the rule which we call as the function. As you study mathematics, you will notice that once you learn polynomials and solving equations and inequalities, all that you need to study onwards involve function. For example, if you want to model the law of supply and demand, you need to know the characteristics of linear function. You need to know its domain, range, graph, intersections, intercepts, and other features in the same way that you study the different organs of the body. When you study the mathematics of a free-falling body, boosting radio signals, or modeling planetary motions, you need to learn quadratic functions and other second-degree relations. If you want to model the growth of, let's say, SARS virus, bacteria, and population growth and decay, you need to study exponential functions. Logarithmic function is used to carbon date fossils, model earthquakes, or even the brightness of some faraway stars. Trigonometric functions model electric current, radio broadcasting, and light waves. Probability function is widely used in artificial intelligence, machine learning, economics, food science research, genetics, etc. Recursive function has a lot of applications in computer science and finance. What is common among them? They are all functions. So functions is the way to model the world. That's why it's very, very important that you need to learn this concept of function. When you go to operations of functions like addition of functions, multiplication of functions, or composition of functions, it's very, very important that you have that mental imagery of the function as the machine that connects the input with the output. With that as our introduction, let's go now to the formal definition of what a function is. So let's begin now with our formal definition. Now, all functions are relations. And a relation is a correspondence between two sets called the domain and another set which we call as the range. Notice that both of them are considered as sets. In mathematics, when we want to show that we have a set, we use this curly bracket in order to list the elements. So we have 1, 2, and 5 are the elements of our set of inputs which we call as the domain. For our range, we have these numbers 2, 3, 4, 5, 7, 2, 3, 4, 5, 7. So what we have here is a relation where 1 is related to 2, 2 is related to 3, 5 is related to 4, 5 is related to 5, and 5 is related to 7. So what we have is a relation. This is not yet a function. This is just a relation. And the set of first numbers is what we call as the domain or the input, and the set of second numbers is what we call as the range or the output. A relation can also be expressed in terms of a set of ordered pairs. So when I say ordered pairs, we have this 1 paired with 2, and we can write that as this ordered pair. And you have 2 paired to number 3 as another ordered pair, 5 to 4, 5 paired to 5, and 5 paired to 7. These two are equivalent. This is in terms of mapping The other one is in terms of the set of ordered pairs. Now, aside from mapping and from ordered pairs, relation can also be expressed as a table. So they mean the same thing. 1 is paired with 2, 2 is paired with 3, 5 is paired with 4, and so on. So one relation be expressed in 3 different ways. There's another one to express that using what we call as the graph. In the xy plane, we put the set of inputs in the horizontal axis. We put the set of outputs in the vertical or the y-axis, and we can plot the points. You have the 1, 2, the 2, 3, the 5, 4, 5, 5, and 5, 7. So all of these mean the same thing. They mean the same relation, expressed in 4 different ways: as a mapping, as a table, as a set of ordered pairs, and as graph. All functions are relations. In fact, a function is a special kind of relations. It is special because a function is a correspondence between 2 sets called the domain and the range, such that to each element of the domain, there is assigned exactly 1 element of the range. What does it mean? When we have this result in our exploration, we had 4 related to 13. 3 related to 10, -2 related to 7, -1 related to 4. You will notice that the elements in our input, in our domain, is not repeated. When 4 is passed through the function machine, there is a unique value, 13, and no other result. What we would like to avoid in the function is like this. My input is 4, and the result is 13. I don't want it to happen that the next time I input 4, the result is no longer 13. It's different. Let's say 25. And the next time I input the same number, the result is different. Let's say 100. Because if that is the case, what's the point of studying this function? Because anyway, we cannot predict what would be the output given an input. Let's go back to the relation that we talked about at the start of our introduction. This kind of relation is not a function. This is not a function. The reason is when 5 is the input, the output is 4. But notice that the same number 5 is the input, the same number 5 is the input. The result now is a different number, it's 5. And the same number 5 is the input, the output is 7. So this is not a function. This is a relation, but this is not a function. When we talk about function, we are interested in that kind of relation where when there is an input, there is just 1 output. Let's say we have these ordered pairs. Let's look at the first numbers in the ordered pairs. So you have 2, you have 4, you have 6, and you have 2 here. Visually, you can think of that this way. You have 2, you have 4, and you have 6, and 2 is repeated. And we have the output of -2, -5, -8, and 0. 2 is paired with -2 in this part. Then 4, -5. And then 6 paired to -8. And then 2 is paired to 0. So this is not the kind of relation that is very useful in mathematics. What we want is, given 1 input, there is only 1 output and nothing else. If that is the case, we call that as function. It is not useful that given 1 input, you have this output, and the next time you use the same number as input, you get a different result. I would like to emphasize this scenario. It's also possible to have this kind of mapping. Let's say you have -2, +2, 3. You have 4, 9. Now, when you have this kind of scenario where -2 is paired to 4, +2 is paired to 4, 3 is paired to 9, is this a function or not? Many students are confused with this scenario. Notice that the input 2 is paired with +4. And then the input -2 is paired with +4. Even if 4 is the output of both -2 and 2, this is still a function. Why? Because we define function as for every input, there is a unique output. Wherever you go, when you input -2, you will always get 4. When you input +2, you still get 4 and nothing else. So even if 4 is repeated, this is still a function. The one that we are trying to avoid in function is to repeat the first element. Once the first element is repeated, that is not a function. It is okay to repeat the second element. If we write this in ordered pairs, we can write that as -2 paired with +4, +2 paired with +4, and +3 paired with 9. We look at the first element, -2, +2, and 3, there is no repetition. If there is no repetition of the first numbers in the ordered pair, then this is a function. Okay, what are the different ways to tell if the relation is a function? When you are given a graph, we are going to use what we call as the vertical line test. Let's say you have a graph like this. Let's say 1 is paired with 1, 2 is paired with 3, this one is paired with the same numbers. Using the vertical line test, if you drop a vertical line, let's say here, it only intersects this point. But if you drop here, it intersects this point. But there are 3 points here that you are going to intersect if you drop the vertical line there. Since there are 3 points of intersection between a vertical line and the points of the relation, then we now say that this is not a function. In order to have a function, any vertical line drawn would only intersect the graph of that relation in only one point. For example, when you have a graph that looks like this, the graph is this curve. This is a function because no matter where you draw the vertical line, there is only one point of intersection between that vertical line and the curve. But when you have a function that looks like this, when you draw a vertical line, it will intersect this point and that point, and so this is not a function. So that is what we mean by the vertical line test. If a vertical line crosses the relation on the graph only once in all locations, the relation is a function. In here, even if there is one point where there is only one point of intersection, we want all locations. So if you drop the vertical line here, there are 2 points of intersection. And therefore, this is not a function. You are not counting the x and the y axis. You are counting the curve and any vertical line. That's the vertical line test. Now, let's look at some of these examples. Is number 1 a function? You have -1, 8 as one ordered pair, 0, 15, 1, -4, and 2, 0. Just inspect the first numbers. There is no repetition, therefore, this is a function. -5, 2, 5, 2, 0, -3, 3, -8. Look at the first numbers. -5, 5, 0, 3. There is no repetition of the first numbers of the ordered pair, so that's a function. -2, +6, -2 is repeated, 0. So since -2 and -2 is repeated, this is not a function. Same here, you have 7, 4, 2, 4. 4 is repeated, so this is not a function. 2, 2, 2, 2. All the first numbers are repeated, so definitely this is not a function. 1, 2, 3, 4. There is no repetition of the first number of the ordered pairs. This is a function. When you are given a table, you look at the elements of the input x. Check if there is repetition, -1, -2, and -3. There is no repetition, so this is a function. Here, 2 and 2 are repeated, so this is not a function. 33, 35, 36. There is no repetition of the input, so this is a function. If you are given this graph, determine if this is a function or not. If you are given a graph, how do we know if this is a function? You draw a vertical line. So draw a vertical line through all these points. Notice that there is only one point of intersection between the point and any vertical line. So this is a function. Now look at this next graph. Here, the vertical line test is okay. But here, the vertical line test failed because there are two intersections. The same here, there are two intersections between the point and the vertical line. So this is not a function. Here, draw any vertical line. Notice that there's an intersection here and another intersection. So this is not a function. Here, you can draw here, you can draw anywhere. Notice that there's always one point of intersection between the graph and any vertical line. Do not look at this intersection. That's not what we are counting. What we are counting is the intersection between the curve and any vertical line. So since there's only one point of intersection between any vertical line and the point of the graph, then we say this is a function. And then let's look at this one. So here, no matter where you draw the vertical line, there's only one intersection between the vertical line and the graph. So this is a function. This one failed the vertical line test because there are multiple points of intersection between the graph and the vertical line. So this is not a function. Here, no matter where you draw the vertical line, there's only one point of intersection. So yes, this is a function. Same with this next example. There's only one point of intersection between any vertical line and the graph. So this is a function. Here, this failed the vertical line test. So this is not a function. And here, it also failed the vertical line test. So this is not a function. Now, challenge. What values of A, so A is this, will make the ordered pairs below a function? So in order for this to become a function, there should be no repetition of the first terms. So that means any real number can be a solution of this, except, these are notation for except, 2 and 4. So any real number can be a solution except 2 and 4. Because if A is 2, then you would have a repetition of the first number in the ordered pair. The same explanation for 4. How about this? What values of B will make the ordered pairs below a function? So this is our B. So you have 5, 7, and 9. In order to have a function, we are only after these first numbers of the ordered pair. So we are not after the second number. So any number could be a value of B, and still this is a function. So therefore, our answer is the set of real numbers. So that's function. Function is very, very important because that is how we model the world. And that kind of modeling is very important because for every input, we know that we can get the same output over and over again. In the next video, we're going to talk about operations with functions and the different types of functions.